Hello, guys. To those of you I got to meet this week, and to those of you I haven't gotten to meet yet that are doing distance learning, it is great to see you. Right now, we're going to talk just a little bit about, our topic of the day is math, and we're looking at place value. Now, a couple of days ago, what we did was we talked about place value in a whole number. For instance, if you had a number like 5,472, and I asked you, what is the value of the 4? You'd think 5,472. The 4 is worth 400. We did several problems like that, and most of the kids I had in class did a very good job of finding the value of the number we asked for. One more example, if we had 72,869, what is the value of the 2? You think 72,000, 2,000. So the 2 is worth 1,000. Today, we're going to look more closely at what it really means to be place value. We will recognize that in a multi-digit number, a digit in one place represents 10 times as much as it represents in the place to its right, and 1/10 as much as it represents in the place to its left. Place value is the value that is a digit based on its place in a number. Each individual number is a digit. We can use the place value chart to help us determine the value of each digit. So if we take the number 134.68 and put it in our number line, it looks like this. So we have 100, 3 tens, 4 ones, 6 tenths, and 8 hundredths. Be sure to line up your decimals correctly. What is the place value of the digit 4 in 134.678? If we line them up, the 1 in the hundreds, the 3 in the tens, and the 4 in the ones, we can see that the 4 is worth 4 ones because it is in the ones place. The value of the 4 is how many times larger than the value of the 6 in the number 134.678. The 4 is one place to the left of the 6. That makes the 4 10 times larger than the 6 in the number 134.68. Each place value is 10 times greater than the place value to its right. What if we shift in the other direction? Then each place value is worth 1/10 or divided by 10 for the one to its left. Knowing place value means that we can follow a pattern when multiplying or dividing by 10. For example, if you have 35.148 times 100, that's where this goes wrong. So we're going to switch to another page. We're going to look at some examples. So here they are. If you are multiplying by a number that is a multiple of 10, that means 10, 100, 1,000, 10,000, 100,000. what you'll do is you will look at the number of zeros in that number. For instance, in our first problem, 47.25 times 100. 100 has 2 zeros. Thus, we would move this decimal point 2 places to the right. If you move the decimal place 2 places to the right from 47.25, you will end up with 4,725, and the decimal point will be after them. Let's try another one. If you start with the number 894.13 times 100, again, we have 2 zeros in 100. Thus, we're going to move our decimal place 2 spaces to the right. That will give us 894, plus we add our 3. And our decimal place will be out here. So the number we end up with is 89,413. Let's try another. If we have the number 73.2 times 10, 10 only has 1 zero. Thus, we're going to move our decimal place 1 place to the right. We will end up with 73 and our 2. And there's our decimal place. So we will end up with 732. Ooh, this one looks big, which looks kind of tricky. But we can use the exact same model to do our math. In this case, we are taking 162.4 times 1,000. How many zeros does 1,000 have? It has 3 zeros. 1, 2, 3. Thus, we have to take this decimal place and move it over 3 times. Let's see if I can make this pen work. There we go. We'll move it over 1, move it over 2, move it over 3. It's a little messy. But if we do that, what we're going to end up with, how do you do that? Because there's only one number. How can we move it over 3? We'll end up with our 162